Hello everyone. In this video we're gonna go over the solutions of problem of the week number 3. Question number 1. This is a question that you probably saw in Calculus 1, and the method needed is just substitution. You just have to make sure you have the right substitution. So here, let's start and assume u is equals to e to the 4x. Then the u is 4 e to the 4x. Also notice from here, if you square u, you will end up with u to the 4x squared, which is equals to e to the ax, which we're going to need in a little bit. If we substitute this and this into this equation, we end up with the following. You can take out the phi because it's a constant, and then notice how this part is just du except for the extra 4 there, so you can just divide by 4, so the numerator becomes just du, and now the bottom, given what I told you here, is technically 1 plus u squared. Recall from Calculus 1 that the integral of dx over 1 plus x squared is equals to tan inverse of x. So we use that, we end up with 5 over 4 tangent inverse of u plus c, that in our case u is equals to e to the 4x, and that's it. Okay. 1b, you can also do it using the substitution method from Calculus 1, which is how I'm going to do it. You can also use integration by parts, but it can get a little more tricky. And also, you do substitution, you may have to try more than once until you get the right substitution. In this case, let's just assume that u will be this part. So let's say u is equals to ln of tangent x. Then the derivative, again from what we did at the beginning of the class, is the derivative of the top. The derivative of tangent is secant square x over itself, dx. Then if we do a bit of algebra, here, this is secant square x divided by tangent x, and forget about the dx for now. Remember, secant square is the same thing as 1 over cosine square x, and tangent is sine x over cosine x. Remember that to multiply fractions, or to divide fractions, you had to multiply by the reciprocal, so this is cosine square x times cosine x over sine x. This cosine will cancel 1 here, so it will end up with 1 over cosine x times 1 over sine x, and then notice the 1 over cosine is just secant, and 1 over sine is just cosecant, and remember all of this has the dx. So technically all of this right here will be the du if you use this substitution. And that will make the problem very easy, but it requires that you do all this trigonometry on the side. But once you have done this, the problem will be very easy. So then if we plug in the substitution, so this will be just u du. Okay, why? Because remember, du, just all of this, is what we have here and here, and this part is what we pick for u. Then what is the integral of u? It's just u squared over 2 plus c. So this is 1/2. U, remember, was ln of tangent x squared plus c. Is this the only way to do it? No, but this could be the easiest, assuming that you are okay with all this trigonometry. Otherwise, you have to use integration by parts, which may not be very friendly either. Now let's try 1c. Just recall from pre-calculus, actually, that ln of x to the p is the same thing as p ln x. And remember, here p is a constant. So technically, what we're really trying to integrate is ln x, the x. We're going to use now the integration by parts method. And remember, the integration by parts is ub minus b du. So you have to pick u and dv. In our case, let's say that u is ln x, so that implies the u is just the x over x. The only thing left here is the x, so that means the b would have to be the x, which implies b is equals to x. So if we plug it into the formula, this formula, then you end up with p. U times b will give you x ln x minus b, which is x, and then du, which is the x over x. Here the x cancel, so you end up with p x ln x minus the integral of the x, which is just x, and then plus a constant, and that's it. Next, let's try 1d. This one is going to require also integration by parts, but before we do that, notice, this is the key to the problem, the x cubed e to the x squared is the same thing as x squared times x e to the x squared. It's just factoring from algebra. We're going to call this u and this one db. So if we do that, then u is equals to x squared. So that means that the u is 2x dx. Then db is x e to the x squared. And if we use substitution, b will be 1/2 e to the x squared. What is the substitution here? Well, it will be u equals to x squared, so the u is 2x dx, and that's why you need the 1/2. Alright, so now we're ready to use the integration by parts formula. So using integration by parts, remember, is u b, so that will give you 1/2 x squared e to the x squared minus b, which is 1/2 e to the x squared du, which is 2x dx. Here, notice that these two cancel, and then we end up with 1/2 x squared e to the x squared minus x e to the x squared. dx. Also, notice one more time that this is exactly this integral right here. So technically you already did this one. It just happens to be the same. So this gives you 1/2 x squared e to the x squared minus 1/2 e to the x squared plus c. You can factor this more, but there is no need to do that. But you can do 1/2 e to the x squared minus 1 plus c. If you get this far on the test, this is good enough. Okay. Finally, number 2, Mickey Ratz claims that the substitution method worked for this problem. Is he correct? The answer is no. He's actually completely wrong. And the reason why substitution doesn't work, the only two choices you have is to say u is equals to x squared. That will give you du is 2x dx. That will not take care of that, so that won't work. The other choice could be this, but the derivative of this one is e to the x squared times 2x, which again is not what you have in here, so therefore it's not going to work. The only method that can kind of work, and I'll tell you what I mean by kinda, is the integration by parts. This question is very, very similar to the one we did before. The only difference is this one, the exponent is x squared, the first one, instead of x cubed. So we can use the same idea. Remember, x squared e to the x squared is the same thing as x times x e to the x squared. So then we can use integration by parts. This will be u, this is dv. So if u is x, then du is the x, and dv, we did this one 3 times already. That implies b is equals to 1/2 e to the x squared plus c, even though you don't need a plus c here. And if we use the formula for integration by parts, then this integral will give you ub, which will be 1/2 x e to the x squared minus b, which again is 1/2 e to the x squared du. So up to this point, this is perfectly fine and legal and everything. The only thing we can do at this point is to take out the 1/2, and if we could integrate this one, then we'll be done. Unfortunately, this integral cannot be integrated. So if for whatever reason you have something like this on the test, you can stop here, and that's the end of the story. The reason why this integral cannot be integrated is because you cannot find any function that when you take the derivative will give you e to the x squared. This function simply does not exist, and this is one of the few examples where it is impossible to integrate something. Okay, so that's why I say this can kind of be solved by integration by parts, but the substitution method definitely doesn't work. Okay, so that's it.